In this video, I will talk about limit and continuity. How do we represent limit of a function? So limit usually we say limit of fx when x approaching a. That's how you write down. So it means when x approaching a, what is the value of y or what is the value of function x? That's called limit. Limit of function x as x approaching a. And if that one is equivalent to, it means that if the limit exists at that point and if it is equivalent to function of a, then we say that function is a continuous at that point. So it means continuity. So continuity of a function means the graph is or function is a continuous. So if you draw the curve, then it will be continuous. You can draw this without taking off your pen. So that's the in general, like a general definition of continuous function. But mathematically you can write down if the limit of that as x approaching a is equal to function of a, then the function is a continuous. And why knowing continuity or continuous function or not continuous function at that point is important, because when we are doing the derivative of a function at a particular point is only possible if the function is a continuous and smooth at that point. Okay, so we'll come to that point later. So first, now we are just learning then how the limits can be associated with the continuity, how we can identify the function is a continuous by using the limit, how we can define the asymptotes, and we will talk another video what is the vertical asymptote, what is the horizontal asymptote, and how we can identify the asymptotes by using the limit. Okay, so you see how all these are relevant. So in this video particularly I am focusing how by looking at the limit we can check that this function is a continuous or not. That's the one thing. And if it is a not continuous, what kind of discontinuity in there. So let's say you have a function which is function x equal to function x equal to function x means y, you know that, so y equal to x square. And if I ask you to plot this one, uh, y equal to x square, so this is basically your function x. And if you do 1 2 3, you know that when we are going for instance 3, okay, then what will give you if x equal to 3, y equal to 9. Like if I do x equal to 3 means when I'm substituting x equal to 3, y will be, or function of 3 will be 3 square, which is giving us 9. So it means at x equal to 3, y will be 9. So let's say this is our, at 3 it would be 9. Okay, so this is, we know, the functional substitution. But when I'm saying limit of x approaching 3, what is the function of x? What does it mean? It means when x approaching 3, and it means when x is going towards 3. So it means you are going from 2, 2.5, 2.99, 2.99999. You are going very close to 3. So if you go from this side, it means you are going from 2.9, then maybe 2.999. So we are going very close towards the 3. And also you can approach 3 in the other side as well. Why not like just coming from 3.5 or 3 point whatever, 3.9, okay, or 3 point, even 3.1. Then you can say okay, it is 3.0001. okay, that means you are coming closer to 3, and that is our 3, right? So you can approach towards 3 from left side, also from the right side. So when I'm saying that x approaching 3, why not saying that from the left side? Means we can say okay, if it is little bit less than 3, so I can say it is 3 of minus. 3 of minus means little bit less than 3. We are approaching from the left side. So it means we are going from 2.9, then 2.9999, even 4 digit 9. And if you put in the calculator, then if I say 2.99999, then it will be function of 2.99999, which is also very close to 9, because you are just basically following. If I just put this color, so you are just following like that, you are going that direction, which is from the left side. I would say in the red color, so it's a 3 minus, so we are going that direction, right? And then you are getting, as I said, you will get 9, because if you put in calculator like 2.99999, it will give you 9, which is little bit less than 3. So we are approaching 3 to from the left side. Okay, now if I say okay, go from the right side, so limit x, if I come towards 3 from the right side, then what is the limit of function of x? So it means if I put 3.000000001, so which is very close to 3, right? Then again you will see that you will find basically you are coming from that side, and obviously when coming very close to 3 you are pretty much very close to 9, so you are getting the same value. So it means the left side limit and the right side limit gives the same value. Okay, and if it is the same, we can straight away write down, okay, limit once x approaching towards 3, not plus minus anymore. So it means when I'm saying x approaching 3, it means I'm indicating it is going from both side, left side and right side. Okay, no more plus or minus. Then I can say it is giving you function x equal to 9. And we already know that function, so x means when x is very close to 3, right? And we know that function 3 equal to also 9, so which is equal to function 3, right? Which is, we know that function 3 is equal to 9, so it's the same. So as per our condition, as I marked here, the limit when x approaches a, if it is same of function of a, in this case x approaches 3, when it's same to function of 3, then we know that function is continuous. So we can now say, okay, limit exists obviously because they are same, and function is continuous. So I can just define it's a continuous function. Okay, function is continuous. Okay, now if I look at another example, let's say if I ask you to plot the graph, what would be it look like? It would be function x equal to x square, same graph, but only it is not applicable, that parabola is not exist at x equal to 3, because x not equal to 3, then only function x equal to x square. It's a step function, right? So it means if I draw the graph, it would be like that, then that, something like that. So what I'm saying, it is 5. So you know that when x equal to is exactly the same graph we are plotting here, function x equal to x square, because function x equal to x is the same graph. So function x we are plotting, but at x equal to like 1, let's say it's a 2, this is 3. So what happened when x equal to 3, it's supposed to be 9, right? As per our previous calculations, when x equal to 3 it would be 9, but you said the graph is not exist at x equal to 3, so it would be like a blank here, because when x equal to 3, in this function it shows 3 square, which is 9, but in the given function is saying when x equal to 3 it is 5, so it means your value would be not 9, it's here. So I am putting a dot here, so it means there is a point here, no more point here, or it's not connected. Okay, it's empty here, and that is called point or removable discontinuity. So the graph is a discontinuous at that point where x equal to 3, so it's called and if you try to explain with the limit, I can say, okay, limit of function of x tends to 3 minus, if I go from the left side, obviously you can see it is 9, because when I'm going from left side, still I'm talking about a little bit less than 3, so it means I'm still applying the first function, which is function x equal to x square. Okay, even when I'm going for the right side, I can write down even straight away here x positive. Okay, then it is also giving you 9. Why? So you can just, I can write down separately, that's fine. So it means I'm doing separately limit x, when I'm coming from the right side, again I'm talking about a little bit more. So when I'm talking a little bit more, still I can apply the first function, which is function x equal to x square. Okay, then I can write down, okay, limit, then we can, when it's left and right same, then we can write down, okay, then it means when x approaching 3, we can straight away write down, then it will be 9. So it means function exists or limit exists, but it is, if I know that function 3, what is function 3? We know that function 3 is 5. So it mean the limit of x approaching 3 of function x is not equal to function of 3, which means the function is not continuous. So I can say just not continuous, because it's not fulfilling the condition. So not continuous. And this sort of discontinuity is called point or removable discontinuity.